Hello, hi everyone. Welcome to the Student the Brand. So, in the previous class, I explained about light reflection and refraction. In that reflection part completed, now I'm going to discuss about refraction part, light refraction. Okay, so let's discuss light reflection and reflection and refraction. So in that first part is completed, light reflection. Now we will discuss about light refraction. Light refraction. Okay, so let's discuss. So I'm taking this one. This is a rarer medium and denser medium. Rarer medium and denser medium. Light ray is moving from rarer to denser. Light ray is moving from rarer to denser. When it is moving from rarer to denser, it will bend towards the normal line. It will bend towards the normal line. So I'm considering here. So this is the incident ray, and this one is a normal line, So this is the refracted ray. So the angle between incident ray and normal line is called angle of incident. Angle between refracted ray and normal line is called angle of refraction. Once again observe. So this incident ray, refracted ray, normal line. Incident ray, refracted ray, normal line. Okay. So laws of refraction. We'll discuss about laws of refraction. Laws of refraction. Okay, first one is incident ray, refracted ray, normal line lies in the same plane. First one, incident ray, refracted ray, normal line lies in the same plane. Incident ray, refracted ray, refracted ray, normal line lies in the same plane. Coming to the second one is, so the ratio of sine of angle of incident to sine of angle of refraction equal to constant. Sine of angle of incidence to, so sine of angle of incidence to sine of angle of refraction equal to constant. Sine of angle of incidence to sine of angle of refraction equal to constant, that is n. So the ratio of sine of angle of incident to sine of angle of refraction equal to constant. So that is I am taking n. So n is the refractive index. So the ratio of speed of light in vacuum by so the ratio of sine of angle of incident to sine of angle of refraction equal to constant. That is n I am taking. N equal to C by V. This is called absolute refractive index. Absolute refractive absolute refractive index. Absolute refractive index. Coming to relative refractive index. So relative refractive index. Okay. So absolute refractive index is nothing but the ratio of speed of light in vacuum by speed of light in medium. The ratio of speed of light in vacuum by speed of light in medium is called absolute refractive index. Whereas relative refractive index means N2 by N1 equal to, so I am taking V1 by V2. So here N is inversely proportional to velocity, right? N is inversely proportional to velocity. That's why I am taking here N21 equal to N2 by N1 is equal to V1 by V2. N12 equal to N1 by N2 equal to V2 by V1. So very important. So related to this one, they will ask one question. So related to this one, they will ask one question. So make sure that you are remembering this one. Laws of refraction. Incident ray, refracted ray, normal line lies in the same plane. Incident ray, refracted ray, normal line lies in the same plane. And coming to the sine of angle of incident to sine of angle of refraction equal to constant. So n is inversely proportional to velocity. So n is inversely proportional to velocity. So n equal to c by v. N equal to c by v. So ratio of speed of light in vacuum by speed of light in medium. Okay, so n equal to c by v. So n equal to c by v. The ratio of speed of light in vacuum by speed of light in medium. So absolute refractive index, that is absolute refractive index. The ratio of speed of light in vacuum by speed of light in medium is called absolute refractive index. So coming to the relative refractive index, n21 equal to n2 by n1 is equal to v1 by v2, n12 equal to n1 by n2 equal to v2 by v1. So this is about relative refractive index. Relative refractive index. I hope it is very clear. So this is the concept. Okay, so this is the concept. Next one. So next one we'll discuss one more, that is so now you can see here now. So this is the one point. This is the rarer medium, denser medium, rarer medium, denser medium. Light ray is moving from denser to rarer. Light ray is moving from denser to rarer. Okay, so here you can observe light ray is moving from rarer to denser here. So it is moving away from it. So angle between incident ray, this is the angle of incident and angle of refraction. Normally, what is the condition? So if the light ray is moving from denser to rarer, it moves away from the normal line. Yes or no? So physics all I am teaching. Okay. User number. So sorry, do you teach maths? So I'll teach physics. Okay, only physics. So in future definitely I'll start maths. Maths I'll start. Okay. Why are you wearing helmet? So this is a part of the teaching. So that's enough. So you can see my shirt. You can see my shirt. So one dialogue is there. So not only person. So wearing shirt also can teach physics. Okay. So my shirt also teaching physics to you. That's enough. So that is a part of. So helmet is a part of the physics. Okay, done. So logic is not that one. So I don't know whether it is a logic, whether it is a science, but this is a part of the teaching. So it is a part of the teaching. Okay. So this is one of the teaching aid, I can say. I can say This is a part of the teaching. So this is one of the teaching aid in my point of view. That's enough, nothing else. So I'm responding to all. So you can see my face also. Okay, so you can see in my channel also, right? So you can see my face in channel. So there are many videos, 4,000 plus videos I made, right? So it's, you can see my shirt also. I only designed, and that's enough. It's a passion for physics. So I'm teaching physics in that passion. So thank you so much for joining and attending and listening, and keep supporting me. We'll discuss physics. Right. Chalo. Get into the topic. So here, rarer medium, denser medium, rarer medium, denser medium. Light ray is moving from denser to rarer. Rarer. Light ray is moving from denser to rarer. Okay. So here you can see. Here you can see. Right. Now, so at certain angle of incidence, so the light ray is move. So here you can see light ray is moving like this. Light ray is moving like this. I am taking here. So normally, what is refraction? The path of the light changes. The path of the light changes at the interference of the two media. The path of the light changes at the interference of the two media. Okay, so light rays, if light ray is moving from denser to rarer, it moves away from the normal line. If the light ray is moving from rarer to denser, it bends towards the normal line. So now I am considering here light rays at certain angle of incidence. At a certain angle of incidence. So this angle at certain angle of incidence. Okay, so the light ray passes or gauges or moves along the surface. The light ray passes or gauges along the surface. It makes 90 degrees with the normal line. It makes 90 degrees with the normal line. Okay, so that angle is called critical angle. That angle is called critical angle. Okay, now, so the light ray is moving from denser to rarer. Light ray is moving from denser to rarer. So here you can see here light ray is moving from denser to rarer. So at certain angle of incidence, the refracted ray reflect back into the same medium, or it makes more than 90 degrees, 90 degrees plus theta. So here you can see at certain angle of incidence. Okay, at certain angle of incidence, the refracted ray passes or gauges or moves along the surface, so that angle is called critical angle. So if the light ray is passing from denser to rarer, okay, so it makes more than 90 degrees in the rarer medium, means it bends towards into the same medium. So light ray will bend towards the same medium. Okay, so towards the denser medium only. So this is called total internal reflection. Once again, light ray is passing from. So normally refraction is nothing but, what is a refraction? So listen carefully, very very important point. Refraction is nothing but. So light ray is moving from denser to rarer. It moves away from the normal line. So at a certain angle of incidence, okay, so this is the angle at certain angle of incidence. Refracted ray passes or gauges or moves along the surface. So that angle is called critical angle. Okay, so the if it is making more than critical angle, more than 90 degrees, then reflect back into the same path. So that is a total internal reflection. I hope it is very clear. Okay, done. So now you can see this is about critical angle and total internal reflection. Now, so we'll discuss one more, that is lens refraction through glass slab. We'll discuss refraction through glass slab. So I'm considering like this glass slab. Then after that we'll go to the lens. Light ray, so this is a rarer medium, denser medium, rarer medium, denser medium, rarer medium, denser medium. So light ray is passing from rarer to denser, rarer to denser. Light ray is passing from rarer to denser. So like this. Light ray is passing from rarer to denser. So normally what happens? It refracts through it. And again here. And now. So here you can observe. Here you can observe. So incident ray, refracted ray, normal line. So now. So the angle between incident ray and normal line is called angle of incidence. Angle between refracted and normal line is called angle of refraction. Angle between emergent ray and normal line, angle of emergence. So here you can observe. So the distance between emergent ray and extended incident ray, emergent ray and extended incident ray is called lateral shift. So this distance is called lateral shift, lateral shift, lateral shift, lateral shift. Okay. So now here I am taking one beaker. So I am taking one beaker like this. Okay. So beaker I am taking like this. So here I am placing the coin. Here I am placing the coin. Here I am placing the coin. So here normally if you are taking, so I am standing before pouring water. Before pouring water. So I place the coin at the bottom of the beaker. So the person is standing here observing. That time the coin, so the person can't able to see the coin. The person can't able to see the coin. After pouring water, so like this, then you can see the water like this. Then the position of the coin is here. So we can able to see the coin. The distance between apparent position to actual position of the coin is called vertical shift, vertical shift, vertical shift. So the distance between apparent position to actual position. So this is apparent position of the coin and this actual position of the coin. Apparent position of the coin and actual position of the coin is called vertical shift. Okay, the distance between emergent rate and extended incident is called lateral shift. Lateral shift. And one more point you can see. So if you are taking the beaker and place the lemon inside of it, lemon inside of it. Okay, so here you can observe. Here you can observe. Okay, so now I'm taking like this. So lemon, if you place it, appears bigger. It appears bigger. So because of what reason? Because of the refraction. And one more thing, if you place the pencil also, if you place the pencil inside of the water, at the interference of the water and glass slab, so here, so actually this pencil, so it appears here, it appears like this. So at the point of interference, it appears to be bent. It appears to be bent like this. So actually it is not like bent. Okay, so it will be like this only. So due to refraction, it appears like that. Due to refraction, so it appears to be bent, right? So here exactly in this position, it appears like this. So normally here. Okay, so this is one example. This is also refraction only. This is also refraction only. I hope it is very clear, right? So this is about refraction. So glass slab, lemon placed in the water and pencil placed, and so coin position. So these three questions are very important. So 3 marks question expected for 3 marks. Now one more example. So lenses will discuss. So related to lens. Okay, so now lens. So real rules of lens. So you are taking this a convex lens. So convex lens, and here this is a concave lens. So optic center f1, 2f1, f2, 2f2. So this is a convex lens. Coming to the concave lens, optic center f1, 2f1, f2, 2f2. Okay. So convex lens and concave lens, right? Now we will discuss about ray rules of concave lens and convex lens. So be ready. So now we will discuss about convex lens. So convex lens and concave lens we will discuss now. Ray rules. So optic center f1, 2f1, f2, 2f2. So one light ray I am taking after refraction passes through focus. First one. Coming to the second one, light ray is passing through focus. Optic center f1, 2f1, f2, 2f2. Light ray is passing through focus. After refraction become parallel to the principal axis. Coming to the third one, so optic center f1, 2f1, f2, 2f2. Light ray is passing through focus, so no deviation takes place. So it will be undeviated light. Coming to the concave lens. So optic center f1, 2f1, f2, 2f2. Light ray is passing after refraction, it will be diverging. So it will diverge the light rays. So it passes through focus. And coming to the next one. So optic center F1 to F1, F2 to F2. Light rays passing through focus. After refraction passes. And coming to the last one. So optic center F1 to F1, F2 to F2. Light rays passing through optic center. No deviation takes place. Okay. So that's enough. So this is about convex lens and concave lens. Convex lens and concave lens. Next one, image formations. Image formations we'll discuss. Okay, now. So convex and concave, we will discuss convex lens and concave lens. So 11th class already started. I'm already discussing. So vectors topics I'm discussing. So I hope already product of vectors. So previous class only completed. So previous class I explained product of vectors topic, motion in a straight line, motion in a plane. So in motion in a plane, projectile motion I explained. So next one, laws of motions I'll discuss. Laws of motion. Next topic is for grade 11, laws of motion. So for grade 12, electric charges and field I will discuss. Electric charges and fields. Okay, so one by one I will discuss. Now, image formation. So optic center here F1. So 2F1, F2 to F2. So object is at infinity, image will form at F2. So how many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. So I am taking like this and one more like this also. After refraction, those light rays will meet at focus. After refraction, those light rays will meet at focus here. Okay. So object is at infinity, image will form at focus. Nature of the real and image is real and inverted. Image is real and inverted. So now nature of the image is real and inverted. Size of the image is highly diminished. So first one. Coming to the second one. Second image formations. Optic center F1 to F1, F2 to F2. Object is placed. So beyond to F1, object is placed. Okay, so object is placed behind center of curvature. One light I am taking like this. It passes through focus. Another light ray I am taking, so it passes through optic center. So image will form between here. So object is placed beyond 2f1. Image will form beyond. Okay, beyond 2f1. Beyond 2f1, image will form. Oh, sorry. Object is placed beyond 2f1, right? Image will form between f2 and 2f2. f2 and 2f2. Second case only, right? This one. Second case. So here image will form between f2 and 2f2. So object is placed beyond 2f1, image will form between f2 and 2f2. f2 and 2f2. Nature of the image is real and inverted, and the size of the image is diminished. Size of the image is diminished. Okay, so these are the two image formations. Next one, object is placed at 2f1. Object is placed at 2f1, image will form at 2f2. Okay, so we'll discuss those points. Ready? Third one, optic center f1, 2f1, f2, 2f2. Object is placed at 2f1. Object is placed at 2f1. Object is placed at 2f1. So image also will form at 2f2. f2 and 2f2. So one light I am taking like this, it passes through focus. Another light ray is passing through optic center. Object is at 2f1. Image also will 2f2. So nature of the image is real and inverted. Size of the image is same size. Same size. Okay, coming to the fourth one. Coming to the fourth one. Coming to the fourth one. Optic center f1, 2f1, f2, 2f2. So object is placed between f1, 2f1 and f1. Object is placed between 2f1 and f1. So one light I am taking like this, it passes through focus. Focus. So in this image will form beyond center of curvature, like here. So image will form 2f2, image will form here. Object is placed between 2f1 and f1, image will form beyond 2f2, beyond 2f2, beyond 2f2. Nature of the image is real and inverted. Size of the image is enlarged. Size of the image is enlarged. Coming to the fifth one. Optic center f1, 2f1, f2, 2f2. f2 and 2f2. f2 and 2f2. Okay. So object is placed at f1. One light I am taking like this. It passes through focus. Another light ray is passing through optic center. So image will form. Object is at f1. Object is at f1. Image will form at infinity. Image is forming at infinity. Nature of the image is real and inverted and highly enlarged. So last case I'll discuss. Okay, so last case I'll discuss, that is very, very important. After discussion, so we'll end the class today. For today we'll end the class. Okay, so we'll discuss later. Hello there. Last case. Power of convex lens is positive, power of concave lens is negative. The reciprocal of focal length is called power of lens. P equal to 1 by f. 1 by f equal to 1 by v minus 1 by u. Magnification is ratio of size of the image by size of the object. Height of the image by height of the object. So v by u, because mirror plus will come. Magnification negative for mirror. Magnification is positive for lens. Last case we'll discuss. So we'll wind up the class. Ready? Convex lens. Optic center f1, 2f1, f2, 2f2. Object is placed between f1 and o. Object is placed between f1 and o. One light I am taking like this. It passes through focus. So sorry. So another light ray passing through optic center. So if you are extending these light rays, those light rays will meet. Object is between f1 and o. Image is forming behind same side of the object. So nature of the image is virtual and erect. Size of the image is enlarged. So thank you so much for joining and attending and listening my class. So this is your Shiva sir from Student D Brand. We'll see you in the next class. Chalo. Thank you.